Hello everyone, welcome back. Well, in previous video, we talked about cloud native and cloud native applications. You can see this video is also in the continuation with cloud native as well. I'll put those in the same playlist as well. So, any guesses what we're going to talk about in this video? If you have seen the previous one, I'm pretty sure your guess would be microservices. Yes, that's correct. Today, we are going to explore microservices and understand cloud native applications better. So, what is microservices? Well, microservices are a modern way of designing and building software that increases deployment velocity by decomposing an application into small autonomous services that can be deployed independently. So it simply means we are breaking an application into small independent services, and all together are making one application, and all these microservices are independent. So by deploying loosely coupled microservices, applications can be developed, deployed, and scaled independently. Because each service is independent, it can be updated or replaced without having to worry about the impact on the rest of the application. What a beauty, right? This means that if a bug is found in one service, it can be fixed without having to redeploy the entire application. It's just one service that got impacted, not the entire application. Independent, small autonomous services, remember? So, yes, that's what microservices gives you. And this is a perfect example of cloud native applications. So all of which gives an organization the ability to deliver value to their customers faster. Because you have broken application into microservices. Now you can deploy small updates or small features in any of the services continuously. So delivery would become faster. So the ability to deliver value to their customer become faster. Remember, in previous video, we did talk about the legacy application or monoliths or traditional software development. Monolithic applications are built as a single large code base. We did talk about that. What does that mean? That means the code is tightly coupled, causing the monolithic application to suffer or rather have challenges. So, what are those challenges? Well, let's try to see a few of them, of course. Monolithic application can become complex and difficult to understand and maintain as they grow. This can make it hard to identify and fix bugs and add new features because it's a one big giant of code. If something happens, the entire application suffers, right? Then, of course, monolithic application can be difficult to scale as they often have single point of failure, which can cause the whole application to crash if a service fails. And deploying monolithic application can be risky and time consuming, as a small change in one part of the code base can affect the entire application. So what microservices are doing, breaking monolith to small autonomous services. That's what we said at the very beginning, right? Here it is. So, which has all those benefits that we talked about in our last video, I mean, microservices, along with fulfilling the challenges of monolith. So, what's that? That's microservices architecture. So microservices architecture is an architecture style that addresses the challenges created by monolithic application, all these challenges or maybe more. So microservice architecture is a way of designing and building software application as a collection of small independent services that communicate with each other through APIs. This allows for faster development and deployment cycles, as well as easier scaling and maintenance than is possible with a monolithic application. Right? So we are talking a lot of good stuff here with the microservice architecture. So let's quickly go and check some benefits. So we have few benefits on our slide. The very first is, of course, agility, because microservices are deployed independently. It's easier to manage bug fixes and feature releases. You can update a service without redeploying the entire application. It makes you follow agile, or agile is actually made for these kind of applications. Microservices should be small enough that a single feature team can build, test, and deploy it. But why? Because small team sizes promote greater agility. Rather, large teams tend to be less productive because communication is slower, management overhead goes up, and agility diminishes. In a monolithic application, there is a tendency over time for codependencies to become tangled. Complexity, remember the challenge? Adding a new feature requires touching code in a lot of places. By not sharing code or data stores, a microservices architecture minimizes dependencies, and that makes it easier to add new features. Teams can pick the technology that best fits their service, using a mix of technology stacks as appropriate. If an individual microservices becomes unavailable, it won't disrupt the entire application, as long as any upstream microservices are designed to handle faults correctly. What I mean by that, let's put this in perspective, or rather give you an example. You can implement circuit breaker pattern, or you can design your solution so that microservices communicate with each other using asynchronous message patterns. Scalability. Services can be scaled independently, letting you scale out subsystems that require more resources without scaling out the entire application. Last but not the least, you can have the database that you want for your service, as each service is independent, and it is much easier to perform schema updates because only a single microservice is affected. Well, these are some wonderful benefits. And of course, we are overcoming the challenges, but grass isn't always greener on the other side, right? So let's check some challenges that microservices has. All right, so what challenges we have? Oh my God, they're like couple of, right? So let's go through this. Well, one of the key challenges of microservices is managing communication between services, because services are independent. They need to communicate with each other through APIs. This can be complex and difficult to manage, especially as the number of services grows. To address this challenge, it is important to have a clear API design with well-defined inputs and outputs for each service. It is also important to have a system for managing and monitoring communication between services to ensure that everything is running smoothly. Another challenge of microservices is managing the deployment and scaling of the services. Because each service is independent, it needs to be deployed and scaled separately from the rest of the application. The decentralized approach to building microservices has advantages, but it can also lead to problems. Lack of governance. You might end up with so many different languages and frameworks that the application becomes hard to maintain. And the use of many small granular services can result in more inter-service communication. Also, if the chain of service dependencies gets too long, then of course additional latency can become a problem. And to be a successful in microservices, we definitely require a mature DevOps culture. Well, in the end, if we need to conclude, microservices architecture focuses on software application as a collection of small independent services that communicate with each other over well-defined APIs. The main advantages of microservices are like increased flexibility, scalability per microservices, efficient resource utilization, and faster development cycles, which are the need of the modern applications. Well, thank you for watching, and you guys have a good day. Bye-bye.